Good morning, everyone. How are you guys doing today? Good. Good to hear that. Today is what? Thursday? Yeah. So next exam will be next week Friday. Next week Thursday, we don't have any class because it follows Wednesday schedule. So we'll go to all of your Wednesday classes next week Thursday. So next week you're going to meet Tuesday, and then you have your exam on Friday. Between that, we don't meet. Okay? And this week you have homework on 5.1, 2, 3, 4. Actually, 5.1 you already did that, right? Tuesday midnight. So for next Tuesday midnight, your homework will be 5.4, 5.2, 3, 4, and 10.2. We are going to 10.2 today. After discussion and one more. And then once we are done with 10.2, we are going to chapter 6. And for the exam, my plan is to do at least first few sections, 6.1 and 6.2. Any question, comments, concern? No? See, yesterday the weather was so sunny and warm, just so nice. And look to this weather. Sergio, I already did that long ago. And I told in last class. The review sheet is on Brightspace. Okay, so in our last class, the last thing we discussed was special formulas. If you don't want to use FOIL to do multiplication, we can actually use special formulas. And one of the special formula was if you have the same binomial you're multiplying twice, all you have to do is so we have the same two terms. Sorry, we have 5x and 2y, and you have a square. Unfortunately, we don't have any exponent rules when you have plus or minus between two terms. So what we do, we take the two terms and we square them. So we always add their squares, but depending on what sign we have in the middle, we take that sign and then 2 times the both term. So this is the outline, the structure for the formula. Now the first one square means we have 5x, so we are going to do 5x whole thing square. And then 2 times their product. So 2 times 5x times 2y. And you always add the second term square. And then we apply our power rule. So 5x whole thing square. When you have more base but one power, we always distribute. So distribute both here and there. That's how we get 5 squared x squared. And 5 squared gives us 25. X squared gives us x squared. Same thing here, we have 2 squared, which is 4, and y squared. In the middle, you multiply 5 times 2 is 10. 10 times 2 is 20. So you have 20. X times y. X times y gives us nothing extra. It's only x times y, which is xy. And that's it. This is what we get when you multiply the same binomial twice. Any question? Go ahead. Yeah. You multiply the constant, you multiply the numbers, and you multiply the variables. So if you multiply 5 times 2, it gives you 10, and then 10 times 2, it gives you 20. So that's how you have 20. And then variable is x and y. When you multiply x times y, it's simply xy. Then we have another special types of formula where we have the exact same exact same two terms, but they are adding and subtracting. So if you observe, we have x and x, the exact same thing. And then we have 1 and 1, exact same thing. So you're multiplying the exact same two terms. The only difference is in the middle. One of them is positive, but in the middle, another one is negative. That's the only difference. So we call them conjugate. When you have the exact same two terms, only the middle signs are different. They have special names. We call them conjugates. Conjugates are like brothers and sisters, okay? They are two brothers and sisters. They always have the same family, only their middle sign is different. Now, when you multiply to conjugate, we love them because their product gives us the first term squared minus second term squared. That's it. So first term is x. So we do x squared. Our second term is 1, which is 1 squared. So x squared minus 1 squared. Now x squared is simply x squared. And 1 squared is also simply 1. So when you multiply, you get x squared minus 1. And we love multiplying conjugates because you don't have to do FOIL. All you have to do is take the first one square minus, always minus the second term square. So who can guess the next one? 4x plus 3 times 4x minus 3. So we have 4x whole thing squared minus our next time is 3. So it's 3 squared. Not 4x squared. It distributes the power because of the power rule. 16x squared. And Jason, what is 3 squared? It's not 6. 9. That's all. Yes, you can use FOIL, but why wasting your time when you know a shortcut? In the exam, you don't have much time, especially in the final exam. You have 30 questions, only 2 hours. So you should learn all the shortcut possible. Always minus. Any other question? So with this, you're done with chapter 5. We don't have anything from chapter 5. And now we are going to 10.2, which is more exponent rules. This time we are going to work with fraction exponents. Fraction exponent is same as you're working with radical. So here it says definition of a to the power 1 over n. A to the power 1 over n. This is same as you have nth root of your base. So you can rewrite radical into exponent powers, exponent, and we can convert exponent into radical. But radical is a special type of exponent. It doesn't give us whole number. It gives us only fraction. What? Where is my rule? I missed my rules. Give me 1 second. Let me put my rules here. How did I miss them? Okay, so these are the new sets of rules. On the left, it says you can convert any radical into exponent powers. So if you have square root of x, this is same as it's x to the 1/2 power. So x to the 1/2 power. If you have cube root of x, this is same as x to the 1/3 power. Nth root of x is same as x to the 1/n power. In other words, if you observe, you see that whatever number we have inside the radical, inside the root symbol, that actually becomes the denominator. So your radical turns into the denominator. If you take 4th root, it means 1/4 power, 1/4. If you take 10th root, it means it's 1/10 power. So radical becomes power by having the number of roots on the denominator. The last one says, well, what if you already have a power on your base and now you're taking the root? So you have a power and you have a root at the same time. So when this happens, you keep your power same, but your radical goes on the denominator. Two powers together, radical. So previously we had, if you have x to the m and n, so two powers together, we multiply them, x to the mn. So you do the exact same thing here. You have nth root, it means x to the 1/n. And now you have a power. So this is same as you have x to the m with 1/n power. So two powers together, you multiply, the result becomes x to the m on the top and on the bottom. And the order, you can place them inside or outside. So this expression is same as nth root of x and then the power m. All three expressions, they are same. But based on whatever is given, you have to always start with the inside. Okay? And then go to the outside. For example, if you have, let's say, square root of 8 square. That's the square. Cube root of 8 square. So we have the cube root inside. So first you're going to do what is cube root. Cube root means multiply the same number 3 times and you get 8. Can you think of a number when you multiply the same number 3 times, it turns into 8? 2. So the inside gives you 2. And then you apply the power outside. So we have 2 square, it turns into 4. So anytime if you work with the radical fast, if it's inside, your life will be easier. The next one is dealing with negative exponent. So like I said before, negative exponent, we don't like them because they are negative. We don't like anything negative in our life. Negative influence, negative balance in the bank, it means you're in debt, or negative people around you. We don't like any of the negative, but we like something negative. Do you know what negative we like in our life? There are some cases where when you see negative, we love it. What is apogeic? Imaginary? No. Think about real life. In real life, there's only few negative things in our life we like. What is one of them? If you see positive, you get sad. But if you see negative, you get happy. Why is that? In real life, I'm not talking about math, okay? I'm talking about real life. Where in real life we like negative things? Huh? 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 Discount? How discount is negative? Because you're paying less money? Good, yeah. So you're happy, but the people who is just giving you discount, they are not happy. Any other example? Genial. Huh? What is this? Virus. Fire? Virus. Oh, virus. Good. Yep. Like corona or disease like HIV. When you see negative result, you get so happy. But when you see positive result, they make you sad, right? So there are a few times we like negative things to have in our life. Except for a few cases, every other thing, when you see negative, we want to get rid of that negative. Like negative people around you, you don't want them, right? Because they will make you suffer. So we try to get rid of them. Same thing when you have a negative power, we don't like them. So you want to do something so that the negative power turns into a positive power. So the method we use is that turn your negative power into a fraction, it will become positive. So x to the negative 1 is same as 1 over x. Similarly, if you have x to the negative 2, it's same as 1 over x to the positive 2. So if you have x to the any negative power, it will become 1 over x to the same thing, but with positive power. And then 15. If you have x to the negative fraction, well, just because it's a fraction, it doesn't mean we have a problem. We still can solve this negative problem by making it into a fraction power. So anytime you see any type of negative power, just change something. So if you see, everything is on the numerator because we have one on the denominator. So when you turn them into fraction, we are basically changing its position. We have the negative part on the top. If you bring it down, it becomes positive. Similarly, let's say you have a negative part on the bottom. 1 over x to the negative 2. If you have negative part on the bottom, all you have to do is bring it on the top and it will become a positive power. So x to the positive 2. So in order to change negative to positive, you just switch the position. That's why we have the rule number 16. Rule number 16 says we have x over y to the negative n power. Now we have a division in our base. So if you apply the rule from the exponent, it's same as x to the negative n over y to the negative n. And we don't like any of them because they both have negative powers. So we bring this x down and we bring this xy. As a result, both of them turn into positive. So we get y to the positive n on the top and x to the positive n on the bottom. And if you want, we can rewrite them as one fraction and one power. So it's y over x over n. In other words, if your fraction has a negative power, all you have to do is switch your fraction, flip the fraction, and then the power negative will turn into a positive power. Any questions so far? No? So these are the new sets of rules. And yes, you must remember them for the exam. Combining these rules plus the previous rules, I'm going to give you 35 questions only on rules. Okay. Now let's do some example. 4 to the 1/2 power. So 1/2, anytime you see 1/2 power, you can actually turn them into square root because we always worked with square root, so square root looks familiar. So you can turn that into square root and you have your 4. What is square root of 4? 2. How can you rewrite the second term? 64 to the power 1/2. This is same as what? Square root of 64. And now it looks familiar. What is square root of 64? 8. So anytime you see square root, yes, turn them into square root, so things will become familiar to you. But except for square 1/2 power, for every other power, leave the power alone because that will make your life easier if you leave it alone. So the next one says the same thing, 64 base, but this time our power is 1/3. So they're asking for what number, if you multiply 3 times, they will become 64. This is what they're asking us. Which number if you multiply 3 times, you get 64. Can you think of the number? Same number you're multiplying 3 times. Any idea? So here I'm going to rewrite our 64 using a power, and we have our 1/3 outside. So we want to rewrite 64 in terms of the power 3. What number to the power 3 gives us 64? 4. So 64 is same as 4 cubed. 4 times 4 is 16. 16 times 4 is 64. All these numbers, either you have to memorize or you have to know how to find them. Now, when you rewrite, something cool happens. We have a 3 power here and we have a 3 power on the denominator outside. So when you multiply them, the 3 power and 3 denominator cancel out. So 3 power, 3 denominator cancel out. And then we have the same base inside, and we have only 1 power outside. When it's 1 power, we don't have to write it. It's 1. We understand it. But many times, you're not going to have 1 on the top. You may have different numbers. So whatever number you have on the top, you bring it down as a power, and then you apply the power. So in other words, it's a cube root. Cube root of 64 is 4. But you don't have to rewrite as a cube root. If you use this method, then it doesn't matter what number they give you, you can easily figure out what the solution is. But if you're used to it converting into a cubic root, no problem, you can do that. And then we have the negative base. Not negative base, the same scenario we did before. So let me refresh your memory. What is negative 4 square versus what is negative 4 whole thing square? What is negative 4, negative and then 4 square? Positive or negative? Why negative? Good. This negative is same as it's negative times the 4 square. So it's negative times 16, which is negative 16. On the other hand, they're telling us, hey, you have a parenthesis. That means whatever inside the parenthesis, you're multiplying the same thing twice. So we have negative 4 times negative 4, that turns into positive 16. And remember, I'm going to give this example in the exam. One with the negative in the front and one with the negative inside the parenthesis. Now, the same rule applies here also. If you don't have a parenthesis in the base, that means that negative is just a multiplication. So this is same as negative times square root of 9. So we have negative, what is square root of 9? 3. But if you had negative 9 way inside the parentheses with the 1/2, this is same as square root of negative 9. But square root of negative 9 means find same number. When you multiply it, find one number. When you multiply the same number twice, the answer is negative 9. Can you do that? Same number multiplied twice turn into negative. Is it possible? If you think it's negative 3, look what happens. Negative 3 times negative 3 turn into positive 9. If you think it's positive 3 times positive 3 is positive 9. So there is no way you can multiply the same thing twice and turn into positive. So this time we say, well, this doesn't exist in real life, but it does exist in the imaginary life. What is the imaginary life? In the imaginary life, we have negative 1 times the positive 9. If you do that, then it makes sense. This thing exists. This is 3. But this thing doesn't exist because we have no idea what is the same number multiplied twice turn into negative 1. Not possible. So mathematician says, well, If it's not possible, then we say, well, this is something that is imaginary. So we write I instead of square root of -1. So the answer here, in real life, it doesn't exist, but in the imaginary life, it's 3i. Okay. So real life, we have no idea, but in the imaginary world, it is 3 and I. Handler, no fun. Any question? So what's the next one? The negative is extra, right? Because it doesn't have any parentheses. So this is same as you have negative times 81 to the power 1/4. And let's rewrite 81 with some number to the 4th power. 3. So 81 is 3 to the 4th. And we like 4 because we have to cancel this denominator. That is our main goal. We don't like denominator, so we cancel this denominator with the power 4. So we still have our negative times the 3. The answer is -3. Similarly, if we have negative 81 with the 1/4, now we have no idea what number when you multiply 4 times turn into negative 81. So this is same as negative 81 with the 4th power, sorry, 4th root. We have no idea. You can write 4th root of -1 and 4th root of 81. But unfortunately, we have no idea what that thing is. This is not I. I is only the square root. If you have square root of -1, it's I. But 4th root of -1, it's not I. So here our answer is simply, it doesn't exist. Eventually, if you take higher level math, you'll realize that 4th root of I is a big number. It's not a number, it's a big thingy with sine and cosine, blah, blah, blah. So that's why for this class, if you don't have square root of -1, for every other even root for -1 doesn't exist. So for square root of negative number, you have to write with I, but for any other negative base with the even power, just write denominator, doesn't exist. Any questions so far? Then let's do more examples. Ignore that. I already explained the rule to you. Here, whatever I just said, the same thing. So let me actually put them together. So it says, if you have a negative inside the parentheses and even number on the base, the answer doesn't exist, or it will have an I, something with I. So here square root of 4, it will be 2i. But for negative base with the even power, even fraction power, the answer doesn't exist. However, for odd root, it doesn't matter. If you observe all the denominators, they are odd 3. So whether you have a denominator inside the base or outside the base, it doesn't matter. You always have some answer. For odd root, negative number does exist. Why? For example, -8. Cube root of -8. It means find one number, multiply 3 times, it turns into -8. It's -2, right? -2 times -3 is 4. 4 times -3 is -8. So yes, you can multiply same number, add many times, and you can turn into negative, which is not possible for even many times. So now let me show you how to do this type of question. All of them, they have 3 on the bottom. So our goal is to rewrite our base using some number to the power 3. So 64, we are going to rewrite. What number, if you multiply 3 times, turn into 64? We already did it before. Which number multiply 3 times give us 64? Huh? 4. So we rewrite 64 as a 4 cube. And we did that because our goal is to cancel the denominator from the outside with the power we have inside. And now if you observe, we have 4 on the base, but this time what power we have on the outside? 2. See this 2? So we do 4 square. What is 4 square? 16. So all of them, they will have answer 16, but depending on whether you have parentheses or not parentheses, your sign will be different. Here it's negative times 64 to the 2/3. So it's negative, we do the same thing. We rewrite 81 as 4 cube, not 81, sorry, 64. So 3 cancel out. We have negative times 4 square. See, your negative is not inside the parentheses. So what's the answer? Positive 16 or negative 16? Negative, because the negative is multiplying. Negative 16, because the negative is outside, it's multiplying. On the other hand, the next one is saying what number, if you multiply 3 times, will turn into negative 64. So which number, if you multiply 3 times, will turn into negative 64? Negative 4. So your negative 64 is negative 4 whole thing cube. We still cancel out our 3, and we have this time negative 4 on the base. And outside we have the square power. This is that 9, it looks like 9. This is 4. So outside we have square power, we bring the square power down, our base is negative 4. So what is the answer this time? Positive 16. So you see, having a negative in the front makes a difference. If it doesn't have any parentheses, then says negative 16. On the other hand, if you don't have a negative, or if the negative is inside the parentheses, they give you the same positive result. Any question? Okay, now it's your turn to do some math. Go ahead, do them. And when you're done, check your answer with your neighbors. Oh, I forgot to take attendance. Six, 5, 7. Janisha. Yeah. Eliza. Absent. Memuna. Fabricio. Sergio. Yeah. Miley. Hemlert here. Oliver here. Himadri here. Mustafa here. Jacqueline. Jiain here. Anaya here. Jason here. Atsiri here. Anthony absent. Joseph. Joseph, how come you were absent in your last class? You had a very fast absence. We missed you. Is everything all right? Sitlali? Seida? Absent. Muhammad? Absent. Ronaldo? Here. Daniel? Here. Jeremiah? Here. Camila? Here. Philia? Here. Haley? Absent. Jasim? Absent. Wow, so many absences. Are you guys done? Jiayin, are you done? No. Okay, let's do them together. And I have more examples, many, many more examples. So, the first one, it says our denominator is 2, all of them. That means you're looking for same number multiplying twice. So keep your outside power and rewrite the inside power. 4 is what square? 2 square. And then what happens? 2's cancel out. 2, 2. So what is left? 2 from the inside. And what from the outside? 3. That means you're multiplying 2 3 times. So what do you get? 8. So it's a real number. We are happy. What happens in the next one? What is this negative sign in the front? It's a multiplication, right? So negative times the exact same thing. You rewrite your 4 as a 2 square. 2, 2 cancel out. You have negative times this 2 and then cube. So this time, what is the answer? -8. And now comes the last one. We have this. Can you rewrite -4 as some number square? 2 square is +4. -2 square is +4. So can you do it? No. So it doesn't exist. The other way around. It doesn't exist in the real life. So for this one, it will become square root of -4 whole thing cube. For this question, doesn't exist is fine because I didn't teach you what is IQ. Look what happens here. We have square root of -1 and square root of +4 cube. That means we have square root of -1 cube and square root of 4 cube. Because the power rule says distribute the power. Now inside tells us that this is I. This inside tells us that we have 2 here. In other words, we have I cube and 2 cube. 2 cube is 8. It's easy. But what is I cube? You don't know that yet. So that's why for this exam, if you see this, DNA is fine. But later, when you go to which section, I don't remember, in the imaginary section, you actually have to do lots of steps like this, all the steps. So for this exam, DNA is fine, no problem. Any other question? Okay. So you'll actually have one of these in the final exam. And definitely a couple in the in-class exam. In the final exam, you have to work with this type of scenario where you have to break down your base into different power and simplify. It will simplify your exponents. So what we are looking for here? One number to the what power? We are looking for a number to which power? 5th power. So Mustafa, do you know what number to the 5th power? No. We don't know because 50 is a big number. So what you do is start with 2 always. Let's see if you multiply 2 5 times, do you get 243? We will not because 2 is an even number, but 243, 3 is an odd number. So definitely it's not 2 to the 5 power. Then we go and see what happens to the 3. So we multiply 3 5 times and see what do you have. 3 times 3 is 9. 9 times 3 is 27. 27 times 3, 81. And then you see what is 81 times 3. 3 times 1 is 3. 3 times 8 is 24. So 81 times 3 is 243. So 243 is what number to the 5 power? 3. And yes, this is a final exam question. So you might see something like this big in the exam. And when you don't know, you always start with your 2 or 3. If it's an even number, start with 3. If it's an odd number, start with 3. If 3 doesn't work, then go to 5. See, 5 going to give you the number. If 5 doesn't give you, go to 7. Okay? So from 2 to 7, the answer definitely will be between 2 to 7. Okay? They're not going to give you something bigger than that. Okay, so you're happy because we found what is 243. Now what happens? What do you do after that? Mustafa? 5 cancel out. That was our goal, to cancel the 5. So you left with what? 3 from the inside and 4 from the outside. And what is 3 to the 4? 81. I don't even understand why we are doing this. Like, what's the purpose? When do you use them in real life? I have no idea. Try the next one. And let me make your life easier. Anytime you have a fraction, the rule says you can distribute your power to on the top and on the bottom, everything on the top and everything on the bottom. So it's 1 to the 3/4 power and 256 to the 3/4 power. Now, what is 1 to the any power? 1. So numerator is simply 1, but denominator, you have to do your math. So it is simply for the denominator, or numerator stays as 1. So go ahead, try. 256 is even number. So try with 2, and then 4, and then 6. One of them definitely will work. You're looking for same number how many times? 4 times, because our denominator is 4. So see what is 2 to the 4, what is 4 to the 4, what is 6 to the 4. One of them is the answer. Ready? So what did you figure out? What number to the 4th power is 256? Huh? 4 to the 4? Is this correct? 4 to the 4? I actually forgot. So 4 times 4 is 16. 16 times 4 is 64. So 64, 4 times 4 is 16. So 24, 25. Yep. 4 to the 4. So we still have our 1. And then what happens? We cancel this 4, so you're left with 4 inside and another 4 outside. Not 4, another 3 outside. Because we cancel the 4. Ah. And what is 4 times 4 times 4? 64. So who is confused? Who needs more help? Anyone? Kind of? Can you do another one? Sure. We have more, but with negative power. They're same. The only difference is the negative power will turn into a fraction. So let me do 16. A, you'll do, so let me do A, you'll do B. So when you have negative power, you have the same scenario. Either, and you have two choices. Either first convert into a fraction or first simplify and then convert into a fraction. It's up to you. So personally, I like to simplify fast and then turn into fraction because we don't like fraction. So our goal is to rewrite 16 as a number to the what power? Huh? We want to rewrite 16 with some number with some power. What power? Not 2. No. What's the denominator? Oh, the answer is 2. Yeah. We look at the denominator always. Denominator tells us what power is supposed to have inside. So same number, if you multiply 4 times, it will turn into 16. The number is 2. So 16 is 2 to the 4. We don't write 4 square. Instead, we write 2 to the 4 because outside we have a 4th denominator. And our goal is to cancel the denominator. We hate denominators. So 4th power and 4th denominator cancel out. And we have the 2 from the inside. And what do you have as a power? -3. And now we turn the -3 into +3. How do you do that? Negative power turns into positive. Mustafa, it flip. Because this, below this we have a 1, so in order to convert into a positive, all you have to do is bring it down. So it's 1 over 2 to the +3. 2 to the +3 means 2 times 2 times 2. What do you get? 8. So answer is simply the fraction 1 over 8. We rewrote this 1 over 8 into a harder number, 16 to the -3 power. Try the next one. Based on the denominator, you rewrite your base. Sergio, which step looks complicated? Any step? No? Okay, try the next one, Oliver. Because you flip them. One goes on the top, and to the negative 3 goes down as a fraction. Ooh, I'm so sleepy, like you guys. And I actually have more. So do all of them with your neighbors. And then do I have more? Yeah, even more. Ha ha ha. So let me actually put all of them together. So 1 minute, Jeremiah. Okay. So you have 5 examples to do. Go ahead, Jeremiah. Never mind. You have 5 examples to do. Try them. Most of them you already did them before, just with a positive sign. And this time you're doing them again with the negative sign. And one of these will be the final exam. Definitely one. Could be more than one, could be 2, I don't remember, but definitely one. Ooh. Then in the next class, what you're going to do? Multiplication rule and more of this. Yeah, we'll be fine. Four times 4 times 64, the top and the bottom. 1, 2, 5. The bottom is 5. It's where is the 16? It's 64. So that's why it's 60. Which is the multiply twice. Don't just mention it. It's negative push power. The basic the whole using but this is negative 4, right? So here, negative 4 cube is negative 64. So negative 4 square. So this is how it is. Negative 4 times negative 4 is 5, 4, no, basic 3. Equal to denominator, odd number is always possible. This could be positive, it could be negative. The main thing is denominator. If denominator is odd, it's possible. One of them. Only cancel into the denominator. So let's do them together in 2 minutes. So we, we keep our power negative 3/2, but we rewrite the inside. So based on the denominator, we see how many times we are looking for the number. So denominator is 2, so you're looking for something square. What square is 16? 4. So the 2 power and 2 denominator, they cancel out. We get 4 from the inside and negative 3 from the outside. And now we don't like the negative power, so you have to turn into fraction. So it becomes 1/4 to the positive 3. 1/64. Same thing here. We rewrite the 8 in terms of 3 power. So what numbers to the power 3 gives us 8? 2. So it's 2 cube. The 3 cancel out. We get 2 with the negative 2 power. And this time we hate the power with the negative. So it turns to 1/2 to the positive 2. The answer is 1/4. And here you observe a denominator. As long as denominator is odd, it's possible. So this is odd. So we keep our power negative 2/3, and we see what number if you multiply 3 times turn into negative 64. What's the answer? 4. Negative 4 times negative 4 times negative 4 is negative 64. So we cancel the 3 power, but we still have negative 4 on the base and negative 2 power on the top. So it turns into fraction, negative 4 to the positive 2, and negative 4 square is negative 4 times negative 4. So it turns into 1 over positive 16. And yes, always carry down your parentheses when your base is negative. The next one, we actually already did that, but we did it with positive power. This time we are doing it negative power. So we know 243, what number to the 5 power? 3. So 3 to the 5. 5 cancel out. We have 3 inside, -4 outside. -4 means fraction, so 3 to the positive 4. And what is 3 to the positive 4? 1 over 81. Same thing is happening here. We keep our -3 4th power and we rewrite 246. What number to the 4th power? 4. So 4th power, 4th denominator cancel out. We have 4 inside and -3 outside. We don't like negative, so it turns into a positive by making it a fraction. And what is 4 times 4 times 4? 64. So tomorrow is Friday. We are going to do a few more examples where we have a combination of negative power, positive power, those things. And then we have multiplication. And then we are going to go to chapter 6. So goodbye, everyone. See you again tomorrow. And remember, before tomorrow, you have your PLTL. Before your class tomorrow.